Let's configure static routing in MikroTik. So in this video, configure static routing in MikroTik. We will briefly discuss what is static routing and why it is important. Next, we will discuss a bit on our demonstration topology to illustrate some use cases of static routing. Next, we will go through each of the topology and configure static routing. And finally, we will test if our configuration is working. Basically, the network administrator will have some decision to make whether to use static routing alone or implement some type of dynamic routing protocol. And in some cases, you may implement both. Static routing is simply the manual way of adding routes or destination networks with their next hop address or gateway, which our routers don't know to begin with. So basically, we are instructing our router to also check these routes in the event there is a packet or information that needs to be sent to a specific destination other than the networks that the router already know. For instance, the connected networks. Static routes rely solely with the decision or the input of the network admin. So there is no algorithm or computation that involved in this to calculate the best path, but rather on what is configured by the network administrator. We will have more videos to come that will touch on routing. So for now, let's leave it at that first. For this video tutorial, we prepared three topologies, a sample demonstration on how we can use static routing and to realize its importance in computer networking. Let's zoom in to our first topology. So we have two routers, MTA and MTB, connected via Ether2. So we can think of it as building A and building B routers. Building A LAN is 192.168.10.0/24 network, and building B LAN is 192.168.20.0/24 network. So we need these two building local area networks to communicate, and for this case, we will make use of static routing. Our MTA router is also connected to an ISP router, so we will illustrate something about it later. So let's perform or configure our first topology. Our MikroTik routers, ISP router, MTA, MTB are already up and running. So please refer to the topology on the right for your guidance. Okay, I'm connected to my MT-A MikroTik router. So this should be this one. So if we take a look at IP addresses to verify if the address are correct. So for Ether2 that is connected to MT-B, so 192.168.1.1/24, which is correct. And for our connection to our LAN, Ether3, 192.168.10.1/24. Then you notice that there is our connection to our ISP router and the address is in D, which stands for dynamic. So these are static addresses. So this is a dynamic address because we have set up on our IP DHCP client that our Ether1 will be a DHCP client and will try to acquire an IP address for any DHCP server. So now let's go to our router's routing table. In order to do that, we go to IP, routes, and here at the routes tab, so here you will see the routing table. So as you can see, we have three entries here in our routing table, and they are with our flag DAC, which stands for dynamic, active, and connected. So we have routes going to 100.100.100.0 network. We have routes going to 192.168.1.0. We have routes going to 192.168.10.0. So meaning to say these are the destination networks that our router knows to begin with. So why we have three routes? Because we have also three IP addresses. So because we have three addresses, so automatically it adds to our routing table. So since we have an interface with this particular IP address on this network, so meaning to say our router knows how to go to 192.168.1.0 as depicted in here. Our MTA knows how to go to 192.168.1.0 network via Ether2 interface. Also, our router knows how to go to this 192.168.10.0/24 network because we have an interface that has an address on that particular network. So in this matter, going to our LAN. And finally, we have also a address on our 100.100.100.2/30 on Ether1 interface such that our routing table has an entry that this router knows how to go to 100.100.100.0/30 network because we have an IP address or an interface which carries an IP address within that particular network. So these are the networks or the destination networks that our router only knows how to pass to or how to connect to. So for instance, does this router knows how to go to quadruple 8, 8.8.8.8? So the answer is no, because if the router has a packet or information with a request going to quadruple 8, so the router will then check its routing table. Do I have a destination address going to 8.8.8.8 or at least on that particular network? So it will check here. The answer is no. It will check here. The answer is no. It will check here. The answer is no. So meaning to say it will drop that particular request. So to prove that, so we go to tools ping and let's say quadruple 8 and we click start. So you see we have a very informative status message, no route to host. So there is no existing route entry for our quadruple 8. In the same manner, if we have to ask whether MTA knows how to go to PCB or at least this LAN B network 192.168.20.0/24, granting that it has a connection to MTB router. So the answer is also no, because the network address 192.168.20.0/24 is not existing here, or at least there is no matching or default route that is present on the routing table. So for example, I need to go to 192.168.20 dot something. So the router will check, do I have a route entry for that? So let's check. Sorry, it does not match 100.100.100. So let's go to the next one. 192.168.1.0, it does not match. And finally, 192.168.10. It does not match because the third octet is 20. So therefore, if I'll do a tools ping again, and perhaps go to 192.168.20.1 or even this interface IP of MTB, if I click start, I will not have any response, and the same error or the same message, no route to host, will also provided to me. So hopefully now you can slowly understand the importance of having a route that will match the destination. So whether the routing entry is static or manual or given to us by a dynamic routing protocol, what matters is you need to have that route. And without that, you cannot go to that certain or specific destination. So for those of you who are already experienced in MikroTik and notice that I have a DHCP client here, so I should have a fourth route because from the DHCP client configuration, so IP DHCP client configuration, so under the selection of the interface, you have the add default route here, which is by default is yes, which I only suppress just to have some simple illustration or explanation before I have this default route. So what I'm trying to say is this is by default yes. I only configure it to have a setting of no. So this time, let's configure it to be yes, apply, OK, and see what happens. So it should add a default route. So we go to IP, so we close this one. We go to our route list again, or our routing table. You notice we have the fourth entry, which is a default route. So a default route, or in some other terminologies, the gateway of last resort, so is a special type of route wherein if your other more specific routes does not match to your intended destination. For example, our previous example of quadruple 8 and 192.168.20, that's something it not falls on this directly connected routes. So now there is now the fourth route. So meaning to say, it tells our MTA in cases your connected route will not help you, please pass it to me and pass it to the gateway or the next hop address 100.100.100.1, which in this case is the IP address of the ISP router. Most often, a destination of any or 0.0.0.0 and any mask or /0 is enough in certain networks. For example, if we go to Google DNS or Quad 8s, it should be okay. So let's test tools, ping, and let's have quadruple 8 this time. So start, and yes, there is now a reply. However, in our scenario wherein we want to go to 192.168.20.0 network, so since there is no matching more specific routes or connected routes, our packet will now be passed or will be going through the ISP router instead, which in this drawing you will notice that it should not be the case. When our PCA would want to communicate to PCB, our MTA should pass it to MTB rather than going to the ISP router. So meaning to say, our PCB does not reside here. So why should our MTA will be forwarding our packet to this ISP router? But unfortunately, that is the case when we don't have more specific static routes. So let's try tools, ping, and let's do a 192.168.20.1 again. Click start, and there you go. You don't have the same message anymore, no route to host, but this time it's still unreachable. So net unreachable will be the error wherein you have a route entry that will match to your intended destination. However, it should not be connected or it should not be reachable because in reality, our intended destination is on another side and not on our internet. So thereby the need of having a new routing entry. So in order to add a new route, let's click the plus sign and you'll have this particular new route window. So under the general tab, what's important for our discussion for this video tutorial are destination address, gateway, and that should be it. There are more settings here that will be discussed in future, but for us, it's destination address and gateway. Okay, so for destination address, so this should be a network address. So in our case, we want our LAN A or our MTA be aware on how to go to 192.168.20, that's something. So that will be our intended destination address, 20.0/24. Now for our gateway, we could have our IP address of the MTB. So gateway is where should you pass it? So in our previous route, in our default route, it is passed to the ISP router address and we have the effect or we have the test result. Our router or our ISP router tells us, sorry, it's unreachable in my side. So meaning to say, we should pass it to another one, which actually knows the network. So in this case, MTB, so in this manner, he is directly connected to 192.168.20. That's something. But in other examples, it could be directly connected or it could not be directly connected. So meaning to say, so it's up to MTB to reach that. But for our very simple topology, 192.168.20.0 is connected to MTB. So therefore, our MTA, we should pass it to our MTB. So we have a gateway. So normally this is a directly reachable address. But there are more advanced configuration, I will say, that will entail it to be not a directly reachable with the use of scopes here. But that is not a subject for our tutorial for this video demonstration. So we will make use of a directly reachable address. So this is the IP address of the MTB. So again, MTA, you want to go to 192.168.20.0. So that's the first one. Next is gateway. So which router or what IP of that router you will pass it to. So again, don't pass it to yourself, 192.168.1.1. So you have two options, 100.100.1, which is going to your ISP router, or going to MTB. So in our case, what is correct is going to MTB. So we have some settings again here, distance, routing mark, and so on and so forth. But this is not covered for our video tutorial for now. So for now, let's click apply and let's click OK. So we now have a new route, which is active static. It doesn't have the D, which is this one is a manual or a static route. So it says here reachable ether 2. So what it tells is the gateway is reachable. It doesn't necessarily mean this destination address is reachable. It is also true with this. So the gateway is reachable 100.100.1, but it doesn't mean that the internet addresses that could be used when having this particular default route is reachable. So it means that I could have a connection to my ISP router, but it doesn't mean that this reachable here is always I have a reachability to the internet sites. Let's now check with the addition of the static route. So we go to tools, ping. So let's ping 192.168.20.1, and yes, there is now a reply. How about from this router going to 100 or the PCB? So click stop and start, and yes, there is a reply. So our MTA is able now to reach this segment. Now let's check if this PCA will be able to reach 192.168.20 that something network. So PCA has an IP address of 192.168.10.100 and a gateway of 192.168.10.1. So let's try. So let's ping 192.168.10.1. Let's try to reach our gateway first, and yes, we have a connection. So now let's try to reach 20.1. Okay, so it has a timeout. So what if our computer, which is obviously if we could not reach our MTB, how much more to reach the PCB? But for the purposes of showing you, so it has also a timeout message. So why is that so? Why our MTA is able to reach our MTB 192.168.20.1 and our PCB, but our PCA will not be able to reach those networks? So the reason why, because MTA has a static route to 20 and MTB knows how to return to this router by via 192.168.1.0 network, which MTB is also aware of since it has a direct connection or it has an interface of 192.168.1.0 network. Therefore, it has a connected route. But in the case of PCA, it is coming from, or its source IP address is 192.168.10 dot something. Once it hits MTB, or once the packet reaches MTB and reaches the PCB and it wants to return, MTB, when it takes a look at its routing table, which we will see it later, so there will be no return route for MTB since we haven't configured MTB yet. So that is why it cannot respond back to PCA, because MTB don't know how to return to you or how to return to PCA, which carries an IP of 192.168.10 dot something. So what we can do is add a static route here telling MTB that if you want to go to 192.168.10 dot something, please pass it to MTA. Okay, so we are now connected to MTB or MikroTik B. So let's check the IP address first. So it has a correct IP address on Ether 2 as well as a correct IP address on Ether 3. So let's check its routing table. So IP routes, and it has two routes because it has only two connected interfaces yet. So there is no connection to ISP. So one is a connected route to 192.168.1.0/24 network and another going to the LAN. So what we suspect is the MikroTik B don't have any route going to 192.168.10.0 network. So let's add. So for destination address 192.168.10.0/24, for gateway, we will pass it to the IP address of our MikroTik A router. In this case, it's 1.1. So destination address, we tell the MTB router, if you want to go to 192.168.10.0/24 network, please pass it to 192.168.1.1. So click apply, click OK. Another variation for this static route, so instead of this specific route, so if you notice on our topology, we have an internet connection via MTA. So MTB could use this path to go to the internet. So therefore, we could create a default route telling our MTB that if you want to go to any IP address, please go to MTA. So again, we could use the default 0000 slash 0 or any IP address, any subnet mask, please go to the MTA. So apply, OK. So now that we have our return route configured on our MikroTik B, so let's try to ping again. So 192.168.20.1, and this time there is now a reply. And let's check the end-to-end connectivity, PCA to PCB, by pinging the 192.168.20.100 IP address. And this time, there is now a reply. Let's check if we will try to configure our static route and modify it in such a manner that instead of the IP address of the next hop router, we will configure with the egress or the exiting interface. So we will modify it instead of the IP. Let's have ether2. So the MTA is done. So let's configure our MTB to be also the same. So but this time we'll disable this for now. So let's change it to ether2 and let's see the effect. Okay, let's try tools ping and let's ping 192.168.20.1. Click start and there is no reply, and obviously 100. Now there is no reply. So for our second topology, we have two routers, main and branch. So they have internet connection. So they are interconnected via a tunnel. So the objective is the branch PC, which carries an IP 192.168.20.100, should be able to reach the server IP of 192.168.10.100. So obviously in this scenario, via the tunnel. Okay, so let's fast forward. I'm connected to the branch router. So if you take a look at IP address, it has an IP address going to the LAN. It has an IP address going to the internet. And our tunnel connection going to the main is up. So basically we are good to go and connected. So let's check the routes, IP routes. So we know how to go to the internet. We know how to go to our tunnel 172.16.10 network. We have a direct connection or our connection to our LAN and our connection to our ISP. So the objective for this is our branch PC will be able to reach our main server. So meaning to say our branch router should be able to help our branch PC to reach 192.168.10 dot something. And if you take a look at the routing table of our branch router, we don't have any specific route to 192.168.10.0 slash something or slash 24, and it has only a default route. So meaning to say, if our branch PC would request our branch router to go to 192.168.10.100, it will now forward its traffic to the ISP router, which is 200.200.200.1. In this case, we don't want that because our ISP router will then reply for a net unreachable since it has no connection to our main LAN or local area network on the address 192.168.10.100. So what we can do now is create a new route to 192.168.10.0/24, this time going to our tunnel. So 172.16.10.1, which is the IP address of the tunnel interface on our main router. So click apply, click OK. We will do the same, which is a return route from our main going to our branch. So this is our main router. So we go directly IP routes and we create a specific static route 192.168.20.0/24, but this time going to our tunnel interface, which is 10.2. So the tunnel interface IP of our branch router is 172.16.10.2. Click apply, click OK, and all that's left is to test whether our branch PC will be able to reach our main server. So this is our branch PC 192.168.20.100/24 with a gateway of 192.168.20.1. So best practice, let's connect and check our connectivity to our gateway, and yes, indeed we are able to connect. Now let's try to reach our main server IP 10.100. Okay, or we could test that one first, and there is a reply to give us some confidence, and we now ping our main server, and obviously there is a reply. As a test, let's try to change, instead of the IP address, let's choose the interface. So PPTP server, because that is my static interface for this tunnel interface. So apply, okay. So let's choose the branch and let's do the same. So this time it's PPTP out because that's the tunnel interface name. So click apply, click OK. Let's check if our branch PC will still be able to connect now that we have changed the gateway address here on our static route. So instead of an IP address, we choose the interface. So ping 192.168.10.1, which is the main IP for the LAN interface. And yes, you are still able to reach. And let's take a look at our server. And there's a slight timeout. And yes, there is still a reply, and we are still able to reach our main server even though we have changed our gateway. So instead of an IP, we choose to configure it via an interface name. And for our last topology, so we have two MikroTik routers that are running a dynamic routing protocol. So specifically open shortest path first, dynamic routing protocol. So in essence, we practically don't need a static route in order for this PC2 or PCs to have an end-to-end connectivity. So our dynamic routing protocol, if you will see later, will take care of that. Okay, so we are connected to OSPF-MikroTik1, so this particular router. So let's check first IP address. So it has two addresses, one going to the OSPF MT2 and one going to the LAN. So since it has a configured dynamic routing protocol that is out of the scope for our tutorial, so it will, as expected, have a dynamic routing entry. So in this case, it has a dynamic routing entry, dynamic active OSPF. So this route is given or coming from the OSPF routing protocol. So it knows 192.168.10 network, but now it knows how to go to 192.168.20 network. So if you will check on OSPF MT2, okay, so IP address, so it has an IP 1.2 going to the MT1, and it has a local area network 192.168.20.1. So it is also running a dynamic routing protocol, so expect under IP routes, it has a dynamic routing entry, dynamic active OSPF, and it knows how to go to 192.168.10 network. So if we verify and test, so this PC2 on 192.168.20.100 IP address should be able to reach PC1 192.168.10.100. And yes, it is able to reach that particular IP. So you might wonder, now that there is a dynamic routing entry from our routing protocol, what could be the need of a static route? So we now have another type or special type of static route, if you may, what we call a floating static route. What it does is it will be on your routing table, however, it won't be active because there is a best path or a best route going to the same network in your routing entry. And only when that particular best route, in this case the dynamic route, will be unreachable or somehow be removed from the routing entry, then that floating static route will kick in and become active and will be used by our routers. So we could create that backup route. So meaning to say, we will add those static route again. So MT1 will have a route going to 192.168.20 network. MT2 will have a route going back to 192.168.10 network. So despite of having a dynamic route, the question now is how can we make a backup route? So not in the scope of this tutorial, but you need to know the administrative distance of your primary route. And for your backup route, configure it to have a higher distance. So for instance, for our OSPF route, if we go in, it has a distance of 110. So we need to create, or for instance, copy this route, and instead of having a distance of 110, we make it as a higher distance. So for example, 120, apply OK. So we now have two routes going to the same destination for MT2. So MT2. So this time, the primary route will still be our OSPF or dynamic routing protocol, and this will be just a backup or what we call a floating static route. Okay, so I have a running or continuous ping from PC2 to PC1. So just in case we will do some changes on our routing protocol, see how it affects our continuous ping. So just minimize this one. And for our floating static route to trigger, we will purposely turn off or disable our routing protocol, which is OSPF, and for in this case we will disable the instance. So by disabling the instance, you'll notice you don't have anymore the dynamic routing entry here, the DAO, and our floating static route kicks in. And now let's see how it affects our ping. So if you see, you don't have any RTO or request timeout because automatically our static route kicks in even though we have some issues with our routing protocol. So it's important to have a floating static route. So in this video, configure static routing in MikroTik. So we define what is static routing and why it is important in our network. We have some various topologies wherein we configure our static route with IP address or regular interface or tunnel interface as our gateway. So we have shown as well that despite of having a dynamic route, we could still add our static route by serving as a backup route. I hope you learned something from this. Thank you for watching.